Hello friends. So let us talk about paradigm. What is paradigms? So sometimes the designer of an interactive system has two open questions. It's like how can an interactive system be developed to ensure its usability, and if it is developed, so the usability of the interactive system, how it can be demonstrated or measured. So paradigms helps to answer this because it enhances the usability, and for itself there's some protocol or some guidelines these paradigms for the development of future products. Now it investigates some principle which happens in the history or which happened in the history so that we understand what are the guidelines, because the principle later becomes the guidelines of our research work. So new paradigms have arisen through this design, and we would understand what are these. So first paradigm for interaction is time sharing. Now, time sharing was in 940s and 50s. The significant advances in computing consisted of new hardware technologies, and they had mechanical relays was replaced by a vacuum electron tubes. Now you have studied those generation of computers and how those tubes are later integrated with transistor, and then integrated with transistors was replaced by integrated chips and so on. So in these changes of these technologies, the time sharing was one of the concepts in which a single computer would support multiple users, and time-sharing system of the 1960s made a programming a truly interactive venture. So it was thought of subculture programming known as hacker, a single-minded masters of detail who took the pleasure in understanding the complexity. That the computer would now project itself as a dedicated partner with individual user. So that means this this allowed to collaborate between the user and the computer, and so it has become a collaborator, so really a model of interaction as a pre-planned activity that resulted in a complete set of instructions which being laid out for computer to follow. Then you have display video display units. So in video display units, like in mid 1950s, researchers was experimenting with the possible of presenting or manipulating information from a computer in the form of images. So it was entirely the image work. How those pixel, how those dot form the pixel becomes those images, and how a brightening contrast comes into the picture. The terms were used when the video, where the images came discovered, like the charts were made. Oh, yes, you have studied this in your computer graphics. So earliest applications of display screen images was developed, and so this this application was done in the military area so as to discover like those enemies and the locations of the enemies, how they look and so on. But that was a later part. So it was a kind of a simulation language that enabled computer to translate the abstraction, whatever they have seen, into a concrete computer image form. So some text is converted into image. That was the latter part. So Sketchpad was the idea. Uh, First, the computer could use more data processing, that they could extend the usability to abstract some levels like visualizing, so manipulating of different representation of same information. Then you have programming toolkits. So in programming toolkits, it was like the human users actually learning from a computer was a contrast to prevailing attitude of this contemporaries that computer was were a purposely complex technology. And so many of these ideas had come like what is so important in the method that is adopted in creating an innovative and powerful interactive system. So the secret to produce computing equipment was helped that problem solving ability. So now, as computer engineers or studying this engineering, the word problem solving arises from your second year. That what is problem solving, and through this mechanism or through some tools or some programming concept, you try to solve the programming problem solving technique. Now, the secret to producing computer equipment that aid human problem solving was aided in a right toolkit. So, the power of programming toolkit was small and it was well understood, and components can be composed in fixed ways in order to create a large tools. Then you have uh, uh, yes, then a Windows system and WIMP interface. Now, Windows system and the WIMP interface is that interaction was with the advent and immense commercial success of personal computing. The emphasis of increasing the usability of computing technology focused on addressing a single user who engaged in the dialogue with a computer. So the humans are not are was able to think like how they can communicate with the computer, or what dialogue sort of what forms you needed. So this a personal computer system which was forced you to progress in order for all subjects needed to achieve some objectives. And it was from the beginning to end, but it was in some pattern, in some structured way. But the ability to address the needs of different user tasks, it was only requirement. So again, it focuses on the requirement, that what was the requirement, and through the requirement, that entire system was accountable. So one presentation about this was achieving this dialogue partitioning to separate physical presentation or from the user computer. Then interaction was based on icon menus and picture. Then next is the metaphor. Now, in developing the logo language to teach the children, it's like how you teach small kindergarten children, how you talk, communicate with them through some tools, through some mechanism, arts and craft activities. So children quickly identify those phenomena, something that actually happens. So what we do, what is the toy? Toy is actually a protocol of, or like a small car. A small car can be is a small example of your big car. So there are the small cars available as a toy, and the children can play with that. So they understand, oh, this is a big car. Oh, I have this car, and so. So these metaphors are usually quite successful to teach new concepts in terms of which are already understood. So it is a kind of analogy. Then you have direct manipulation. So what is direct manipulation? Now, direct manipulation highlights a feature of like, okay, I'll explain. The direct manipulation is rapid feedback, which is one of the feature of the interaction system, which known as direct manipulation. It's something like graphics based interactive systems such as Sketchpad. When you draw, a Sketchpad is one of the ability, a feature that is given by your system. So as long the user system dialog remained largely unidirectionally from user's command to system command, a line prompt. Okay, from the user command, you take the user command or this command line arguments and so on. So there is a command which is given to the system, but later the it highlights the direct manipulation interface like visibility of the object of interest, incremental action of at the interface with rapid feedback of all actions, reversibility of all actions so that the user are encouraged to explore without a severe penalties. So the direct manipulation interface on the desktop metaphors, it requires your documents or folders. So on your table you have a range of documents and folders, and they are available, made visible to the user. So how this is a feature, how this is shown on your computer. So do you have a folder like folders like folder, a document? These terms are literally used in your system with the files and directory. The same concept which we feel, which we have seen in real life. It's now available on your computer. So this is a metaphor that has been used, and it can be termed as a direct interface, direct manipulations, because this is directly manipulated with your hardware things. So in command line interface to your filing system, it is normal that typological errors is constructing. So in a command line argument, if you forget the syntax, if you can't remember the syntax, and if you mistype the name, so what happens is it gives you error that file not found, that file is not in so and drive, please try the name. But that was using the keyboard. But if you use your pointer device, and so you will able to face it. Now the next is incremental action of at the interface with rapid feedback of all actions. And they are, as I told, a synthetic correction of all actions so that every user is a legal operations. Then you have a hypertext. So where does this hypertext is used for? Hypertext in order to reflect such non-linear words and associate with linking schemes. So hypertext normally arrives uh, in your web page or when you use your web design. Normally for your web design, it arrives at hypertext. If you we define it as a hypertext, so in order to reflect the use of such non-linear thing. So normally when we write the text, when we try to make create a web pages, so we use the hypertext markup language and so. But let us see what this hypertext is defined over here. So it's a major drawback of the research effort that it becomes increasingly difficult to keep in touch with the growing body of scientific knowledge. Now, this is some part of theoretical. Okay, so I'll get back into the point. Now, what happens is sometimes the written words like non-linear text and other forms, a traditional paper is read from the beginning to end in a linear fashion, a synchronized fashion. But within that text, there are often ideas or there are footnotes which urge the reader to do it, but they can't. So the hypertext is like reflected a non-linear structure, so that hypertext has a image also. So whenever you read, you got a link to click, you got images, you got text in a colorful form, which helps the reader to read it more interestingly. Then you have next is multimodality. So multimodality system will you still use the keyboard and a pointing device such as mouse for input and are restricted to a color display screen with some outside capabilities for output. Then a modal interactive system is a system that relies on the use of multiple human communications channels. So each different channel for the user is referred to as modality for interaction. So what that makes sense. So in this sense, all interactive systems can be considered multimodal for human. They have the visual and the haptic, I mean, with the touch channels in manipulating a computer. So multimodal or multimedia and virtual reality system form a core part of current research. An example, we can give a gesture model with a pointing device by speaking, indicating what operation to be performed on selected objects. So it's just like a robot. The next is language versus action. So this language, a language is to communicate and the action is to perform certain work. So whereas it is a true that a direct manipulation interfaces makes more tasks easier to perform correctly, it is equally true that some tasks are more difficult. So if it is not impossible sometimes. So the image what we projected from direct manipulation, it's a way of interface for the system from the outside world through the outside world. Now actions performed at interface replace any need to understand the meaning of a system level. So there is the user gives the interface instruction and then the responsibility of the interface to see that those instructions are carried out. Yes, because those instructions can be in the form of a language. Then interpretation does not require the use to understand the underlying the system structure. We don't require how the system is working. We don't get into the detail of the system structures. We just want that action to be performed once the command is given. So an interesting combination of the two occurs in the programming. So when a user can perform some routine task, the action paradigm and the system records in a generic procedure. So in this way, we conclude our paradigm. We'll do the next topic at the next session.